Hello. So this is the second live interactive session for the course Structural Geology offered by NPTEL. My name is Rajiv Mukherjee and I will be hosting these live sessions. And today's topic of discussion is measurement of structural attributes. So as we know that this is the outline of the online course of structural geology. So we already discussed some of the basic concepts of structural geology, including the scale dependence of the different kind of structures, their homogeneity, heterogeneity, etc. in the previous discussion session. And today we will talk about the uh, concepts regarding structural elements, measurements, and stereographic projection. That is the lecture material for week 2. So today's live session, the date is 3rd August 2024, and this is the session link to join the discussion session. So these live interactive sessions will be hosted on every Saturday each week for a duration of 12 weeks. So about today's live session, uh, I just briefly summarize the lecture content of week 2. So in week 2, we learned about the definition of structural attributes such as strike, dip, pitch, plunge, rake, etc., their geometric relation and measurement techniques, description of equipment and their use, fundamentals of geometric projections, stereographic projections in structural geology, interpretation of structural data from stereonet problems. So this was the overall uh, goal for week two's lectures. And for today's topic of discussion, we will be deriving some trigonometric relations between the structural attributes. And then we will go for solving conceptual questions related to structural attributes and the stereographic projections. And finally, we will summarize and conclude today's discussion, and we will also go for a brief planning for the upcoming live session. Uh, I am audible, right? Can you please, anyone confirm?
Yes, sir, you're audible.
Okay, thank you. So, um, so before going on deriving some of the trigonometric relations between different kind of structural attributes, I would like to briefly, I mean, recap the basic of trigonometric identities. So sine theta, if this is a right angle triangle, then if this is the angle we are talking about theta, then sine theta is basically opposite by hypotenuse. Cos theta is the adjacent or the base by hypotenuse. Tan theta is basically the perpendicular by hypotenuse, and cosec theta is the inverse of I mean the reciprocal of sine theta. Sec theta is the reciprocal of cos theta, and cot theta is the reciprocal of tan theta. And similarly, these are some of the Pythagorean relations we talk about in trigonometry. That is sine square theta plus cos square theta is 1, sec square theta minus tan square theta is 1, cosec square theta minus cot square theta is equal to 1. So I guess if you just know these relations, then we are fine to go for the derivation of different kind of projections and the relation between these kind of structural data. Okay, so first we will talk about geometry of a lineation on a plane. So consider this as an inclined plane. Okay, and there are some angles, there are some lines. So we will describe all of these components that are drawn here. By the way, this diagram has been taken from a book called Structural Geology and Introduction to Geometrical Techniques by Donald M. Regan. This was published in 2012. So it is a very good reference for studying the geometrical relations between different kind of structures and for practical problems. You can look for the book in internet. Okay, so first is, let me switch to the pen mode. So this plane, this is an inclined plane, and from the week 2's lecture we already know that for structural elements, to define an inclined plane, or to define a plane, we need two data, that is the strike of the plane and the deep amount of the plane and the dip direction. So now once if you know the strike of the plane, you can easily derive the dip direction using the right hand rule. But in this case we will be not just using the right hand rule, we will derive some trigonometric relations. So the line OA, this is the strike of the plane. Okay, so this is the inclined plane, and this line OA, this is the strike line of the plane. So strike line by definition is any horizontal line on the plane. Okay, and the length here, we have considered the length x. In reality we don't actually need to consider the length of these structural attributes, but to derive a trigonometric identity or a trigonometric relation, we need to put some arbitrary lengths to these different I mean structural features to derive the relation. Okay, now so we can see that the plane is dipping in its maximum amount along this direction, right? The line AY. So we can call the line AY as the dip direction of the plane, right? And we have given a magnitude here as well, that is C. Once again, we don't actually need to give magnitude or the values in real life, but for the sake of derivation, we are assigning some values to them. And AB, so AY, this line lies on the plane, right? Now AB, this line, as you can see, this line AB is actually not lying on the plane, but it is a horizontal line. That means we are projecting the line AY to the horizontal plane. So we can say that AB is the projection of the line AY on the horizontal plane. Okay. So if this is our strike line, that is OA, then AB makes a right angle with OA. So this angle is 90 degree. And it is obvious that the dip direction will always lie perpendicular to the strike line, right? Okay, so first we will be defining all the linear components and then we will go for the angular components. BD, or sorry, BY, this is basically, or we can, or if we consider the triangle ABY altogether, so if we consider the triangle ABY, this triangle is basically part of a vertical plane cutting across the inclined plane. Okay, so then we have this BY, this line linear segment BY. This is basically the, I mean, edge of the vertical plane we are talking about, right? Now, why do we consider having a vertical plane cutting across this inclined plane? Because as we know from the concept of, or the definition of deep and strike, so deep is basically that how much inclined the plane is. Now, how much inclined the plane is, actually to measure this angle, you need a vertical wall between the horizontal plane and this inclined plane to actually project these two planes and actually see their intersection to get the angle. So that is the concept of having this vertical plane that is cutting across, right? So edge of the vertical plane. And now there is another vertical plane passing through this, I mean cutting across this inclined plane. We will talk about it later, but let's just say that this is the edge of the vertical plane 1, right? And we have also assigned a magnitude, that is D. All right, now we have completed all the components of this ABY triangle. Okay, so the length of AB has been assigned as W. So we have completed the triangle ABY. Now just describe the triangle OBY. Okay, so what is OY? Now OY is the lineation that we are trying to find. Its, I mean, a trigonometric relation between the different attributes of a lineation with its, I mean, with the plane that contains it, right? So OY in this case is the lineation, and we have also assigned length, that is L. Now, if we pass another vertical plane, so if you can see this plane, that is OBY. So if we pass another vertical plane like this from OY or through OY, then this surface that is contained with the triangle OBY will be the part of another vertical plane, right? So triangle OBY, so this is part of another vertical plane, I mean passing through OY, cutting across the inclined plane. Okay, and OB, as you can see that OY is lying on the inclined plane. So this line lies on the plane, and the line OB, it is basically a horizontal projection of the line OY. Okay, and finally we have the triangle OAB. So triangle OAB is formed as a result of the intersection between two vertical planes, and if we just extend the horizontal plane like that, so we will get OAB, that is a part of the horizontal plane. So OAB basically is the part of a horizontal plane intersecting the inclined plane. So this is more or less the description of different lines and lines lying on the plane, and we have also considered two different um, vertical planes that are imaginary planes. Of course they are passing uh, through this lineation and the dip direction. So one is this plane that is cutting across the inclined plane like this, and another is this plane that is cutting across the inclined plane like this. Now we have the angles that these lines have made on the surface, right? So by definition, delta, that means this angle. So this angle is basically the deep angle of the plane, right? Because AEAY, this is the deep direction, and we measured the angle with respect to a horizontal line, that is AB. So therefore delta is our deep angle, right? Okay. and then we have another angle called R. So if you follow it correctly, then you can see that R is the angle between the line OA and the lineation OY, right? Sorry. Uh, so if you have a lineation OY, then the angle R is basically between the strike line and this line OY. So this is basically the pitch of the lineation. Okay. Now there are two more angles, that is beta and P. Now if we follow the angle P, we see that there is a horizontal line called OB, and we measure the angle P between OB and OI. So OB is the horizontal projection of the line OI. That means with respect to a horizontal line, we are actually measuring how much the original line is inclined, right? So if this is our horizontal line, I mean, if this is our original line and we have a horizontal line like this, so we are measuring how much inclined this actual line is with respect to the horizontal line. That angle is the plunge amount of the lineation. So this P is basically the plunge of the lineation. Now we have another angle called beta, this one. So beta is basically the structural bearing of the lineation. Right. So we will talk that what is, I mean, we will discuss that what is this actual structural bearing means. But for now, let us move on to the next slide. So this diagram is basically simplified and projected diagram of the previous diagram. So we have this lineation OY as usual, and we know that this is a horizontal plane OA, I mean OABC. So this is horizontal plane, and OAYX, this is our inclined plane, right? So the angle between this horizontal plane and this inclined plane, that is delta. This is the deep angle of the plane. Clear? Now, as we talked in the previous slide, so this is our lineation. So if we project the lineation onto the horizontal plane, we will get the line OC, sorry, OB. OB is the line. So OB, this is the horizontal projection of line OY. Okay. And we see that beta, this is the angle between OA and OB. So OA is basically the strike line, and OB, which is the horizontal projection of the line OI, in terms of structural attributes, we call this line as the trend of a lineation. Okay. So this beta angle therefore means we are measuring the angular difference between the strike and the trend. So this is the strike and this is the trend, and this is the angular difference. So we can write it like this: beta is the angular difference between strike and the trend of a lineation. Of course, a line cannot have a strike. I mean, if a linear component, that is a lineation cannot have a strike. Strike should always, by default of its definition, it will always be of a plane. So strike of the plane. Okay. So we have the strike of the plane and we have the trend of the line. So the angular difference between the strike of the plane and the trend of the line is called the structural bearing, or beta. So if strike angle is phi and trend angle is theta, then beta is basically phi minus theta, right? So this is the relation you have to remember. That is, structural bearing is the difference between the strike angle and the trend of a lineation, and the rest remains the same. That is, R is the pitch, P is the plunge, delta is the dip of the plane. So based on these definitions, we will derive three important trigonometric relation between strike, dip, pitch, plunge, and trend. All these things are interconnected to each other. So if we have any of these data, any three of these data, we can easily have a trigonometric relation to get the other three. Okay. So let's look at them. So the first relation is a trigonometric relation between strike, dip, trend, and plunge. So what is strike? So strike is any horizontal line on a plane, right? So in this case, we will define strike the strike line is OA and it has a magnitude x, right? Consider strike angle as phi. Now, what is strike angle? So, say for example, the OA line is like this. So, you know this is the OA line. So, this is the strike direction. Now, if the north lies in this direction, then we will have an angular difference with respect to the north. This angle is phi. So, the strike angle is basically the azimuth of the strike. How much it is deviating from the north direction. Okay. So, that angle is phi. Now we will define the deep amount, that is delta, right? And deep direction, of course, it is 90° plus phi, following the right hand rule. Okay, so this is the deep amount and this is the deep direction if this is the strike. So this is the strike and this is the deep. I mean, this is the deep amount and this is the deep direction. So this is deep direction, this is deep amount, and this is the strike line. So our goal is to find a trigonometric relation between strike, deep, trend, and plunge. So we have the horizontal projection of the line OP, which is OB. OP is the trend of the lineation, right? Now, which one is the lineation? Lineation is the OI. OB is the trend of the lineation, and trend angle, of course, consider this angle as theta. Then by default, structural bearing, or I'm not by default, by definition, structural bearing. Which one is the structural bearing? Beta. Beta is phi minus theta. Okay. Now we have to find a relation between beta, delta, and we also have a find the relation with plunge. So what is the plunge? Plunge is basically the angle P. So we have to find the relation between P, beta, delta. Okay. And beta by default involves phi and theta. So we have actually we will be establishing a relation between phi, theta, P and delta. Right. So if we closely look for the triangle OBY, that means this angle, this triangle OBY. So this is the opposite or the perpendicular. This line is the base. OB is the base, BY is the perpendicular, and OY is the hypotenuse. So if we define tan P, tangent of P, that will be the perpendicular by base. So the perpendicular is BY and base is OB. That means we have D over L prime. Okay, so this is the value. Also, if we calculate, and now if you see for triangle ABY, we can calculate tan delta. So in case of triangle ABY, we see that BY again is the perpendicular and AB is the base. So tan delta will be the perpendicular by base. That means BY by AB, which will be D by W, right? And finally, for the triangle AOB, if you observe the triangle AOB, that means this horizontal triangle AOB, we see that we have angle beta here, and with respect to beta, we can find the relation between W, that means AB, and OB, that is L prime. So in case of triangle AOB, we can define sine beta. So sine beta will be again perpendicular by hypotenuse. That means AB by OB. So AB is W and OB is L prime. So you can see that we have these three relation: D by L prime, D by W, and W by L prime. So if we just multiply D by W with this W by L prime, we will get D by L prime, right? So that means D by W is tan delta, W by L prime is the sine beta, and D by L prime is tan P. So we derive a relation tan P is equal to tan of delta times sine of theta minus, sorry, phi minus theta. So this is one trigonometric relation between the plunge amount, the deep amount, and this is strike, and this is the trend. So this is the simplified trigonometric relation between strike, deep, trend, and plunge. Tan of plunge is equal to tan of deep multiplied by sine of the difference between strike and trend. So this is the first trigonometric relation that we just derived. So I will pause for a minute and then we will go for the next derivation. So if anyone is having any doubt, they can please ask. So after deriving these trigonometric relations, we will go for solving some MCQ problems as the previous week. Okay, so this was the first trigonometric relation between strike, dip, trend and plunge. Now we will see a trigonometric relation between strike, dip, pitch and trend, right? So just like before, our strike is OA and the length of this line is X. Strike angle is as usual pi, right? Dip amount is delta. Dip direction is AB and the length is W. Okay, we have strike, we have dip direction. Now we will need to identify which is the trend, sorry, pitch and trend. So what is pitch? So pitch is basically the angle between any lineation and the strike of the plane. Measured on the plane itself. So that is the definition of pitch. And here we have the strike line OA and the lineation is OY, and we measure the angle R, which is the pitch, right? So pitch is basically R measured between OA and OY. Okay. And of course, trend angle is theta and the line is OB, which is the again horizontal projection of the original lineation, that is L. Now we have to find a relation between strike, pitch, trend. So we have pitch angle R, we have dip amount delta, we have strike angle phi, and we have trend angle theta. We have to derive a relation between them. Okay. So if we define tan of R, so now if we consider a triangle OAY, in that case we will get, for the triangle OAY we can calculate tan of R, tangent of the pitch, that will be the perpendicular by hypotenuse, perpendicular by base. So in case of triangle OAY, the perpendicular is AY and the base is OA, right? So AY by OA, which means AY has a length of C and OA has a length of X, right? Mm, then so we can find out the value of x as, therefore x can be written as c by tan r, right? Now again for triangle OAB, we see that we have x, w and l prime, right? So if we take the tangent of this angle beta, we can find the relation as AB, that means this is the perpendicular, and the base OA. So AB by OA, we will have W by X. Therefore, we can write that tan beta is equal to W by X, means C by tan of R, right? That means W by C times tan of R. So what does W by C means? W by C is nothing but the relation between the base and the hypotenuse for the angle ABY, which contains angle delta. So W by C is basically AB by AC, AB by AY, which is cos delta, right? So this is cos delta times tan of R. So we can refine the relation as tan of R is equal to tan beta by cos delta, or that means tan of R or is equal to tan of pi minus theta divided by cos delta. So if we know the pitch, the strike, the plunge and the deep amount, we can derive a trigonometric relation amongst them. Okay. So this was the second trigonometric relation that we talked about. So if you have any doubt, please ask. I can surely discuss about them. Otherwise, I will give you a minute to see the results if you have any doubt. Otherwise, we can go to the next derivation.
Sir, you if you please tell something about rake.
Rake and pitch are the same. I mean,
Same.
mathematically, those are the same.
Okay. Okay. Thank
So
you.
that is why even I mean, R has been considered for the term rake. So R for rake, you can see it like this as well. So this was the relation. I mean, if you know the strike, deep, and trend, you can easily calculate the rake or the pitch of the lineation. Okay, so coming to the third and the last derivation for today's discussion, which is the trigonometric relation between strike, pitch, plunge, and trend. Right. So we have this master diagram here, and again, this diagram has been taken from this very informative and exhaustive book called this Structural Geology and Introduction to Geometrical Techniques, which is written by Donald M. Regan. I urge every one of you to please look into this book. It's very informative. Okay, so let us derive this relation. Uh, Again, we will define strike, pitch, plunge, and trend. So strike is, as usual, it is the OA line, and we have considered the length x. Strike angle is phi, and then we have pitch. So pitch is basically the R angle between OA and OB. Here OB is the trend and angle is theta. And finally we have plunge P, which is angle BOY, angle boy.
Sir, angle R is between OA and OY.
Yes, sorry, yes, I R is angle between OA and OI. You're right. I have to correct it. Beta is between OA and OB. Yes. And plunge is the angle BOY. So now we need to find a relation between this angle P, angle R, theta, phi, and relate them together. So for first of all, if we consider the rake or the pitch, which is the angle between the line OA and OY, we see that if we uh, calculate the cosine of this triangle, we will have a relation between the triangle which will involve the length L, length X, and by combination we will be involving the triangle OAB and OBY as well. So we have this common side on both of them. So if we just calculate the cosine of R, so therefore for triangle OAY, cosine of R will be the base by hypotenuse. That means OA by OY, and that will be X by L. So therefore X will be, of course, L time cos of R. And for the triangle OAB, for the triangle OAB as well, we can see that we can find the value of X through the cosine of angle beta. So for triangle OAB, cos of beta will be OA by OB. That means X by L prime. Therefore, X is equal to L prime cos of beta, right? So if this is 1 and if this is 2, we can equate them. Therefore, L into cosine of r is equal to L prime of cosine of beta. Therefore, cosine of r is basically L prime by L cosine of beta. Now, L prime by L means we will be involving the triangle OBY, right? So if we consider the plunge, sorry, yes, if we consider the angle plunge, then cosine of plunge will involve OB and OY, right? So for triangle OBY, cosine of the plunge will be OB by OY, and that is L prime by L, right? So if we substitute this value here, we get cosine of the rake is equal to cosine of the plunge times cosine of beta, which is basically phi minus theta. So this is the trigonometric relation between the strike, trend, pitch and plunge of a lineation. So this is the cosine law, and the previous one was the relation between the pitch, the trend, the strike and the dip, and the first one was the relation between plunge and the strike and the trend and the dip, and this is the pitch and the plunge and the strike and the trend. So these are basically pretty easy trigonometric relations. They are nothing serious about them. These are just trigonometric calculations. We have to put different sines and cosines and adjust these values to get a trigonometric relation like this. So if we summarize the relations, so these are three important relations for any kind of quick derivation of the values of pitch, plunge, strike, dip, whatever, etc. In these common structural attributes for lineation, and these are essentially the relations between a lineation and the foliation in that sense. So the first is the relation between strike, dip, trend and plunge. So that is tan of plunge is equal to tan of dip times sine of strike minus trend, right? Second is the relation between strike, dip, pitch and trend. So that is tan of the pitch or rake is equal to tan of this phi minus theta, that is strike minus trend, divided by cos of delta. And finally the relation between strike, pitch, plunge, and trend. So that relation is cos of the rake or the pitch is equal to cos of the plunge times cos of strike minus trend. So these are three important relations that are that gives you a quick result while calculating the values of essentially plunge and the pitch, and of course the trend of the lineations, and it also involves the dip and strike of the foliation or the plane which contains the lineation. Okay, so one thing I would like to say that I looked into the NPTEL portal again, that is the course dashboard, and you can find the recordings of these live sessions just on the left side where you find the different lectures for different weeks, and you can go down. At the bottom we will find the problem solving sessions. It is written as problem solving sessions. You can click there and you can easily access the YouTube link for the recording sessions and the Google Drive folder link where you can find all the lecture materials that I will be uploading. Right? Okay. So this was the derivations, and now we will solve some problems here. So first three problems will involve the formula just we derived, and then we will go for quick sessions regarding these structural attributes. This kind of question they easily, I mean, commonly appear in GATE, NET, and, JAM, or any kind of competitive examinations. Right? Okay. So the first question here tells that a foliation plane of attitude 045 60-degree deep contains a mineral lineation. If the trend of the lineation, so we find already two information, that is, this is strike phi, this is delta deep, right? And if the trend of the lineation, that means we are talking about the angle theta, is 0.75, then the plunge amount of the lineation, then find the plunge amount. So we have to derive the plunge amount of that lineation on the foliation plane. So if we just quickly write the formula, I mean not the formula, what the data we have phi, which is 0.45, and then we have theta, which is 0.75. So theta minus phi or phi minus theta, whatever it is, this is 75 minus 45, that means it is 30-degree. So this is basically the value of beta, structural bearing. And then we have delta, which is 60 degrees, right? In question we have to find what is the value of plunge. So these are the relations. Based on these relations we can use this first relation where we have to find the value of p. We have been given the value of delta and this difference, right? So we can write the formula tan of p is equal to tan of delta and sine of beta, right? So tan delta means tan 60-degree times sine 30-degree. Sine 30-degree is half, so half the times of tan 60-degree. So then you can find the plunge amount P is equal to tan inverse of half times tan of 60 degree. So now you solve this problem and say, I mean, tell me what is the value of P here.
It's 40 degrees, sir.
You have calculated.
Calculated, sir.
Okay. What is the value of tan 60 degree?
Yes, sir. 1.73 is a 1060.
Tan 60 is 1.73. Acha. So, oh, okay. I mean that in that sense, yeah. So that means 1.732 divided by 2, that is
It will be
0.86.
0.86 and tan inverse of
Tan
0.86 is
inverse of
around 40 degrees.
0.86. It around 40, 41 degree around. So the angle is 40 to 41 degree. Okay. So this is the plunge amount, and this plunge amount. So whenever you write plunge, you always mention the trend. So 40 to 41 degree towards 0.75. So that's how you complete the data. So this is the plunge amount of the lineation. Okay.
Sir, amount will be written after or 0.75.
So it is written. It is written like this: the plunge amount towards this direction.
Okay.
Okay. So the second question is a foliation plane of attitude 0 to 0.45 degrees. So again we have our phi. This is our delta. Contains a mineral relation like that. If the pitch, that means R or the rake of the lineation is 30 degree, find the trend of that lineation. So again we talk that we have phi 0 to 0. We have delta, which is 45 degrees. We have the rake or the pitch as 30 degrees. And then we have to find basically the theta. So in that case, we will apply the formula tan of rake is equal to tan of pi minus theta divided by cos of delta. Or we can write directly um, not, I mean, just or tan of pi minus theta is tan of r multiplied by cos of delta, or phi minus theta is basically tan inverse of tan of r times cos of delta, which gives us the theta is equal to phi minus tan inverse of tan r into cos of delta. Right. So we have the value 20 degree minus tan inverse of tan r, that means the rake of the pitch tan 30 degree times cos delta, that means cos of 45 degrees, right? So 20 degree minus tan inverse of tan 30 is 1 by root 3, it's 1 by root 2, so we have to find 1 by root 6, right? 嗯 it's 0.41, so it's 22, it is getting tan inverse of 0.41, so that is a value which is around 22.3 degree. But I guess I just, when I was making this problem, I did not consider this value. So just for the sake of argument, if we just change the value of the strike, right, we can easily, I mean, if we make this value as 040, for example, so other things, it is not changing, the values are not changing. So if we just make this 040 40 degree, then we can have the trend as 40 minus 22.3, so that means near about 18 degrees. Now another thing is that even if we get a negative value from this, that means uh, the numerical value of the trend is getting larger than the strike value, So that means actually it is farther away from north than the strike is. So that is why this phi minus theta may not always be a positive quantity. It can be a negative quantity as well, but we just simply take the absolute value. So but for the sake of this problem I just changed to just show how the formula works. But actually it can be both positive and negative, because we actually don't know the absolute value of this theta. It can either be larger than phi, or it can also be less than phi. And that the physical meaning of that thing is that it can either be uh, nearer to north than the strike, or it can be farther away from north than the strike line is. But anyway, I just wanted to give you the essence of this formula. How does it work? So this is the relation using, I mean, this trigonometric relation we can establish the, I mean, we can easily find out the trend of a line. Okay. The third question involves structural bearing of a lineation is 45 degree. So structural bearing means we are directly talking about the beta angle, and that is being given as 45 degrees on a foliation plane dipping at 35 degrees. If the plunge amount of the lineation is measured to be 25 degrees, so that means we have been the we have given the angle P, then find the pitch of the lineation. So this is, again we have beta, which is 45 degrees. We have delta, which is 35 degrees, and we have uh, plunge, which is 25 degrees. But I guess we have already established a relation like cos of rake is equal to cos of plunge multiplied by cos of beta. So we don't need actually this delta value or the deep amount. We can easily calculate from this formula alone. So we have to find the value of the pitch. We have the plunge, which is 25 degrees. So cos of 25 degrees times cos of 45 degrees. So therefore pitch, yes, therefore pitch R is equal to cos inverse of cos of 25 degrees multiplied by cos of 45 degrees, right? So the value will be, so this is near about 0.91 times, this is 45 means it is 1 by root 2. It's times 0.71. So the value is 0.91 times 0.71, which is 0.65, cos inverse 0.65. So it is near about 49 degrees. Okay. So this is the pitch of the lineation on the foliation plane. Okay, so this was the third problem using the third formula. Now let us see other some of the other problems. So question number 4 is that a horizontal bed is folded in a manner that the axial plane of the fold is vertical and strikes north south. If it is a non-plunging fold, the amount of dip of the bed in the hinge zone of the fold is, the options are given: 0, 30 to 50 degrees, 50 to 70 degrees, and option D, it is 90 degree. So can you say which is the right answer?
Sir, sir, 90 degrees.
Axial plane is vertical and strikes northwest. Deep of the bed are bed at the hinge zone. So this is a fold which is non-plunging. So and we have the axial plane like this. So this axial plane is vertical, you can see from the image. And if we consider, so this is the north and the fold is non-plunging. That means what? The fold is, there is no angle at the hinge with respect to the fold axis. There is no angle. The fold axis is making no angle at the hinge with respect to this axial plane. So that means if we pass a horizontal plane through this, what angle should we see? So if the beds were at 0 degree, so what angle should we expect just at the hinge here? So it is obviously it is 0 degree, because the beds, they're dipping steeply on both the side, but the dip is decreasing gently and it is becoming 0 at the hinge, and then it is again increasing. So the condition is that the fold is upright and non-plunging, and we see that the beds are steeply dipping on both the sides, and of course the axial plane is vertical. So we say that the correct answer is option A. That means the beds are at the hinge zone are perfectly horizontal. Okay, next question. A dipping limestone bed with a true thickness of 5 meters shows an apparent width of 10 meters on a horizontal surface. What is the true depth of the limestone beds in degrees? So we have a surface like this, and we have a limestone bed which is dipping like this. So this is the true thickness of the limestone. Okay, and this is the apparent thickness. So OA, and if we draw 90-degree line across this, OAB, right? So this is the deep angle of the limestone bed. OA is the apparent thickness. and OB is the true thickness. Then we need to find out the value of theta, right?
Sir, I think
So
AB will be the true thickness.
yes, sorry, AB. AB is the true thickness. So therefore, if we consider sine theta, so we'll get AB by OA, right? We have been given AB is the true thickness, which is 5 meters, and OA, which is the apparent thickness, that is 10 meters, right? So which is half. That means theta is basically what? 30 degrees. So option C is the correct answer, which is the deep amount of the limestone bed. Okay. Now the sixth question is continuing to the previous question. That means we can draw this like this. So we have this limestone bed. At what horizontal distance? I mean, along what distance in meters from the exposed upper surface? That means from here of the exposed upper surface of the limestone bed, should a vertical hole be made so as to intersect the top of the bed at a depth of 100 meters. So consider that if I am drilling from this point, say this is point X, and I am drilling from here vertically, and I touch the top surface of the bed, say this point is Y, and this has been given that the distance XY, it is 100 meters. Okay. So from what distance should we start? I mean, should we consider this horizontal line? I mean, the horizontal distance from the export surface, so that we get a depth of 100 meters. Now the question is that the problem is that the question is not stating that from which part should we start. Should we start from this point, or we should start from this point? Because as from the previous problem, we see that this is already a 10-meter exposure. But
The
I guess
30-degree dip is given, na sir?
yes, you can
Yes,
consider the dip of
30
30
degrees.
degrees.
So vertical impact is 100 meters. It means uh, we need this means that this hypotenuse will be 100 meters. We only calculate the base.
So hypotenuse is not the 100
This
meters. The perpendicular distance, that is the 100 meters.
this much vertical impact we want, na sir?
Yes. So this XY is 100-meter given. We just need to find if this point is A. Consider this point, this starting point. Let us see what happens. So if we just consider this starting point A, then we need to find the distance AX. Right. So tan of 30 degree is XY by AX, right? So AX is equal to 100 meters divided by tan of 30 degree. So that means the answer is
173.2.
exactly. So that means we should consider from this point. That is why.
Uh, I have told hypotenuse that will be the perpendicular. Sorry.
Yes, that XY is the perpendicular, AY is the hypotenuse.
Sorry.
So the correct answer is option B. Okay, this was the sixth question. We have four more questions to go. I hope we can cover by time. Okay, seventh question is a strike slip fault dips. Sorry, a strike slip dip fault strikes 030 and dips 45 degrees. Then the net slip of the fault plunges 30 degree towards 045, for 0 degree towards 030, 45 degree towards 120, and 90 degree towards 030. So which one will be the correct answer?
Sir, D. B for 0 degree towards 30 degree.
Yeah, exactly. So for explanation, we can say that it is given it is a strike slip dip fault. That means the fault probably would look like this. So this is one block. So this is the movement. So any kind of strike slip fault, whether it is a deep fault, it's a vertical fault, whatever, what kind of fault it may be. So if this is, so I mean, if the fault surface is vertical, then we just simply say it as strike slip fault. But if the deep is anywhere between 0 to 90 degree, we generally call it as a strike slip deep fault. So a strike slip fault means the net slip of the fault will be parallel to the strike of the fault plane. So in that case, strike is the horizontal line on a plane, and that is why the net slip, the plunge of the net slip on a strike slip fault is always 0. Okay. Okay. So the eighth question is structure contours of a bedding plane at 100-meter interval are spaced in such a manner that the horizontal equivalent distance is 65 meters. The deep of the bedding plane is 33 degree, 47 degree, 57 degree, and 87 degrees. So what are structural contours? So if you have seen a topographic map or topo sheet map, so you will see that there are some contours given. Contours are surface or lines connected to equal elevations in a region. So this line contains points which are of equal elevation. So contour line means there are elevation difference in the region. So for example, we have a contour like this. So this contour says 500 meters. This contour says 400 meters. This contour says 300 meters, and so on. That means, so if I follow this line from this point to this point, the elevation difference is 400 meters, and this point to this point, the elevation difference is, again, this is 100 meters and this is 100 meters of elevation difference, right? And from this distance we can calculate the slope or the dip of the structure or slope of the plane, whatever. Now if you follow this trajectory, you will see that the slope is relatively gentle. But now if you come to this point, I mean, if you follow this trajectory here, or traverse here, not trajectory, so from this point to this point, it is a gap elevation difference of 100 meters, and again from this to this, the elevation difference is also 100 meters. So you can see that the horizontal distance is much smaller in this case, from in this trajectory compared to this trajectory. So in this case, obviously this the slope of the I mean region will be much steeper compared to this region. So this is how we calculate the cross section along a topographic along a particular topography or a geological structure using these contours, and also we can estimate the slope of the region, whether it is a steep slope, or whether it is a gentle slope. Now using this concept, we will be calculating this problem.
Sir,
So
sir,
yes,
there is a question, sir. A slope and dip should be can be different, sir.
yes,
Some
of course,
uh,
slope, as in there can be,
it
I
may
mean,
be same, but in many
no, no,
mostly
I mean, slope is basically when we talk about the topography.
topography.
That in that case we use the
Or
term slope.
that
But
will be
whenever we have a structural, I mean, a structure, a bed, or a lithological unit, a rock unit, in that case, to define their structural attributes, we use the term deep. But essentially, they both, mathematically, they both represent the same thing. That is the inclination with respect to the horizontal plane. Slope is also the same thing.
but if erosion is more, then that dip has similar, and erosion is more, then slope will be changed.
Exactly. So deep more or less remains permanent if the
Yeah,
upper
yeah, yeah.
part,
Right.
we have a soil cover over this rock unit, and this rock unit is being exposed constantly due to erosion of the upper soil surface. So the slope of the soil surface that controls the topography, it will be changing because of this erosion. So the slope will change, but since the rock is eroding much less than the upper soil cover, so the deep will somewhat remain constant. And overall deep remains constant because it is a structural attribute. So in a region, deep actually cannot change because it can only change through deformation. Erosion can only change the slope of a region
Yes,
we are
yes.
talking about.
Right, right.
Okay, so as we see that there is two contours, and the horizontal distance represented here is 65 meters, but these two contours, they represent an elevation difference of 100 meters. So if this is contour A and if this is contour B, then this distance, if this is X and Y, so Y minus X is basically 100 meters. So this gives us a profile like this. So we are standing at point Y, and now we are going at point X. Now we are going to point X, and X is actually a projection of the point X prime, which is at a smaller elevation, and the difference is basically 100 meters. So if we join these 2 points, we can get the value of the deep of the bed, provided that we know the distance, which is xy is 65 meters. So we have 100 meters here and 65 meters over here. So we can calculate tan theta, which is x prime by xy, which is 100 by 65. I guess the value is, just let me check, 100 by 65. Yeah, so this is close to 1.53, and then theta is tan inverse of 1.53,
57.
which is 57 degree, close to 57 degree. So in this case, option C is the correct answer. The dip of the bedding plane is 57 degrees. Okay. Coming to the next question, question number 9. It says that which one amongst the following is the correct attitude of a plane? We have four options: 221 degree, 95 degree; B, north 45 degree west, 40 degree southeast; option C, 090 degree west; and option D, 89 degree and 75 degree south. So closely, thoroughly see these options and tell me which one you think is the correct answer.
Sir, D.
Option D.
Yeah.
Yes, it is correct. Why the others are not correct? So if you simply follow this point, the strike may be correct,
But tip is not 90 degree.
but 95 degree deep doesn't make any sense, right? So in reality, planes cannot actually have more than 90 degree deep. So it is actually dipping on the other side, on the other direction. So the strike may be correct, but the direction is wrong.
वो डायरेक्ट नहीं कर सकते कि द स्ट्राइक इज नॉर्थ ईस्ट सॉरी नॉर्थ वेस्ट साउथ ईस्ट then deep will be either side. It can't be in southeast.
It can be answered in that way. I'm I'm even I am also saying the same thing, but I'm just
Yeah,
showing through
right,
the
sir.
stereo net. Yes, you are right. So north 45 degree west means you go 45 degree from north, so somewhere between north and west. So this is the strike. So this means this is the strike. So if this is the strike, passing a great circle will go either like this or like this. So the plane will either dip along northeast or it will dip along southwest, but it cannot dip along southeast. It is not possible. Now again 090 degree west. So 090 represents the east west line. So one end of the strike is 090. So either the plane, so the dip direction has to be 90 degree from the strike line, right? So 090, if this is the strike we are giving, according to right hand rule, the deep direction should be south, but not west. So following that, option C is also wrong. And following this right hand rule, we can say that if 89 degree, that means close to 090, is the strike of our plane, then following the right hand rule, the dip should be along the south direction, and the amount is also correct. So following, I mean, considering all these things, option D is the correct answer.
Sir, just a query, sir.
Yes, please.
Sir, this in C option,
Yes,
90 degree is a strike. It means that
yes,
the strike is east west. East west
yes,
strike. So plane can dip either south, north also. Na? Either side it can dip.
yes. But for the, so the right hand rule says that you have to go,
Clockwise.
I mean, clockwise
Okay.
from the given strike direction. So if it was 270,
Okay. Okay.
if the strike was given 270, then you would consider the deep along north, I mean deep direction along north.
Okay.
But according to the right hand rule, if since the strike is given from the east end, so I have said
Okay.
that the
Thank you.
deep is along south. Yeah. Okay. So the last question here is that a sandstone bed whose altitude is 09030 is exposed on a flat surface, right? The true thickness of the bed is 100 meter. Find the width of the outcrop of the sandstone bed on the ground along north 30 degree east. So we have to not only calculate the apparent thickness but also along a particular direction. So first solve this problem, which is given as that the deep amount is 30 degree. So say for example, this is the flat exposure, ground exposure of the bed, and we have this point xy. We draw a perpendicular line, and this is z. So yz is the true thickness, which is 100 meters. Since this is 30 degree, so this will be, so sine theta is equal to yz by xy. Since this is 30 degree means half, therefore xy will be 200, right? So this will be 200 meters. Now the interesting part of the problem is that we have been given that this is the, if we consider this is the east west line, and this is north, sorry, this is north and this is south, whose attitude is 09030. So the bed, of course, has a strike of 09030. That means the bed is dipping towards south. So this direction is basically south. The bed is dipping towards south. That means the apparent thickness along south will be the largest. I mean, not largest, we don't know exactly. We should calculate it. But apparent thickness, this xy, is actually along south. Okay, since the bed has attitude 09030. So if we have been asked to calculate the apparent thickness of this outcrop along north 30° east. So if we go 30° from here, that means if this is 30° and this point is O, we have to calculate the length OY. Okay. So in case of triangle OXY, we can say that cos of 30° is equal to XY by OY, right? Since XY is 200 meters, we can calculate the value of OY as 200 by cos of 30°. So what will be the value? So this will be 200 by 0.86 roughly. So it will be roughly around 233 meters. So the thickness, the apparent thickness along north 30° east is 233 meters. Okay. So this was the second live session. So we have solved all the problems. So in this in this live session, we derived three important trigonometric relation between the structural attributes. Followed by that, we also solved some multiple choice and numerical type questions related to the structural attributes we commonly use. So in the next live session, we will be discussing about strain and deformation of rocks. Followed by the next week, we will be having a discussion on stress. So until then, I encourage everyone to see the week 3 lecture contents on strain, and then on next Saturday, that is 10th August, we will again have this live discussion session where we'll be discuss some, I mean, if you have any doubts regarding the concepts of strain, and we will also solve numerical problems regarding strain and deformation. And by that time, I will be uploading these recordings videos to YouTube, and I will be sharing the lecture contents in a Google Drive folder, which you can access through the course dashboard under the section given of problem solving sessions. So until then, uh, thank you very much for joining this live session.
Thank you, sir.
Okay.
Thank you, sir. Thank you.